Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. So in this video we'll talk about independent events. Two events are independent if probability of one event does not depend on the happening of the other event. Okay. So if events A and B are independent, then happening or not happening of event A doesn't change the probability of event B. Similarly, happening or not happening of event B doesn't change the probability of event A. Okay. So for example, if we toss a coin 2 times, so we are tossing a coin 2 times here. The probability to get a head or tail on the second toss doesn't depend on what happened with the first toss. Okay. Similarly, getting a head or a tail on the first toss doesn't depend on what will happen on the second toss. Okay, so the probabilities are independent here for both the events. Thus, these two events are independent events. Now, we look at some examples. We saw the example of tossing a coin 2 times. So over here, event A is getting a head on the first toss. Event B is getting a head on the second toss. These events are independent events. Okay, because if we get a head on the first toss, getting a head on the second toss, the probability is still 1/2. Okay, even if we don't get a head on the first toss, means if we get a tail on the first toss, still probability to get a head on the second toss will be 1/2. It is calculated independently of what happened before it. Okay. Now the second example says that a dice is rolled 2 times. Event A is getting 4 on the first time and event B is getting 2 on the second time. Okay. So again, these two events are independent events because probability to get a 2 on the second time doesn't depend what happened when I rolled the dice for the first time. The probability to get a 2 on the second time will be 1/6. Okay. So now if A and B are two independent events, then probability of A and B is equal to probability of A multiplied by probability of B. So now we look at a question first. It says if probability of event A is 0.4 and that of event B is 0.6, find the probability that both the events will happen together if the two events are independent events. Okay, so the question gives me that these two events are independent events. So here if we want for both the events to happen together, that means A and B are happening together. So we have to calculate the probability of A and B. Okay, as these events are independent, probability A and B will be equal to PA into PB, which is 0.4 into 0.6, which will be 0.24. Okay, thus probability that both the events happen together is 0.24. Okay. Now we'll look at the generalized OR rule for independent events. So the generalized OR rule says that probability of A or B equal to probability of A plus probability of B minus probability of A and B. And if two events are independent, probability of A and B will be equal to probability of A multiplied by probability of B. Thus for independent events A and B, probability of A or B will be equal to probability of A plus probability of B minus probability of A into probability of B. Okay, so this is the OR rule for independent events. Now, before moving ahead, we'll discuss about a normal deck of cards. So a normal deck of cards has 52 cards. Okay, so out of 52 cards, 13 cards are hearts, 13 cards are diamonds, 13 cards are spades, and 13 cards are clubs. Okay, here hearts and diamonds are red in color and spades and clubs are black in color. So of the 13 card of each type means either heart, diamond, spades or club. Okay, 9 cards are number cards, okay, which are 2 to 10. 3 cards are face cards, which are J, Q and K. Okay, and one card is an ace card for each type. Okay, so this is about cards. Now we'll understand what does it mean to draw out items one at a time with replacement. So when items are drawn out one at a time with replacement, it means the first item is drawn out and then placed back. Okay, then the second item is drawn out, placed back, and then the third item is drawn out and placed back, and so on it goes. So an example over here states that when three cards are drawn out one at a time with replacement from a normal deck of cards, the following sequence takes place. The first card is drawn and then placed back in the deck. Then the second card is drawn and then placed back in the deck. And the third card is drawn and then placed back in the deck. Okay. So this is how the sequence takes place when we withdraw anything with replacement. Okay. So now if you look at it, drawing items one at a time with replacement forms an independent event. Okay. Because if I place back the card, I am making the deck original again. Okay, so if there are, say for example, in a normal deck of cards, there are 52 cards. If I take out a card, see it and again place it back, for the second card still there are 52 cards. So the probability of second event will not depend on what happened in the first event. Okay, so that is why whenever you withdraw an item with replacement, it is an independent event. Okay, we'll look at an example now. Okay, so now we'll look at this question. The question says that three cards are drawn out one at a time and with replacement from a normal deck of cards. Find the probability that all of them are hearts. So here when the first card is drawn, there are 52 cards in the deck and 13 of them are hearts. So the probability for the first card to be heart will be 13 by 52. Okay, because number of successful outcomes can be any 13 and the total number of outcomes can be any 52. Okay, so applying the basic probability formula, we get probability for the first card to be heart equal to 13 by 52, which is 1 by 4. Okay, now the cards are drawn with replacement. So after looking at the first card, it is placed back into the deck. Okay, so now when the second card is drawn out, there are still 52 cards in the deck and there are 13 hearts. Okay, so the probability of second card to be heart will be again 13 by 52. Okay, similarly probability for the third card to be heart will be again 13 by 52. Okay, because cards are drawn with replacement. Okay, okay, and we have to find the probability for the first heart and second heart and third heart. So that will be probability of first heart multiplied by probability of second heart multiplied by probability of third heart. Okay, because these are independent events. So the probability to get the first heart and second heart and third heart will be 1 by 4 into 1 by 4 into 1 by 4, which is 1 by 64. Thus probability for all of them to be hearts will be equal to 1 by 64. Okay. Okay, now we'll look at conditional probability. When the events are not independent, then the probability of an event depends on the outcome of other event. Okay, so calculating this kind of a probability is calculating a conditional probability. Okay, because then the probability of that event depends on the outcome of the other event. Okay, so conditional probability is represented as probability of A slash B or PA slash B. Here PA slash B means probability of A given B has happened, and probability of B slash A means probability of B given A has happened. Okay. Now for conditional probability, probability of A and B will be equal to probability of A multiplied by probability of B given A has happened. Okay, or probability of A and B can also be written as probability of B multiplied by probability of A given B has happened. Okay. Now when items are drawn out one at a time without replacement, then conditional probability is calculated. When we say without replacement, then it means that we are not replacing them back into the deck or the bag from where the items are withdrawn. Okay. Now suppose you draw 3 cards, one at a time, from a normal deck of cards without replacement. Okay. Here when the first card is drawn out, there are 52 cards. Now the first card is taken out and kept away because I am drawing it without replacement. Now when the second card is drawn out, there are 51 cards left in the deck. Now you can see the probability of second card has changed because we have only 51 cards instead of 52 cards. Okay. Now the second card is kept away here. Now when the third card is drawn out, there are 50 cards left in the deck. Now you can see that the probability of third card has changed because instead of 52 cards, we have only 50 cards in the deck now. So the third card is now kept away. This is the meaning of withdrawing an item without replacement. Okay. So in this case, conditional probability is calculated. Okay. Now we'll look at a question here. The question states that 3 cards are drawn out one at a time and without replacement from a normal deck of cards. Find the probability that all of them are hearts. Okay. So when the first card is drawn out, there are 52 cards in the deck and 13 of them are hearts. Thus probability for the first card to be heart will be 13 by 52. Now the cards are drawn without replacement. Okay. Thus the first card is kept away. Now we have 51 cards and 12 hearts. Okay. Why 12 hearts? Because we will assume the first card to be hearts because we are calculating probability of success. So all of them have to be heart. So a heart has already been withdrawn in the first event. So I have 12 hearts and 51 cards. So the probability for second card to be heart will be 12 by 51. Similarly, probability for third card to be heart will be 11 upon 50. Because when we withdraw the second card, we keep it with us. So we have 50 cards left and 11 hearts left now. Okay. So the probability now for the first heart and second heart and third heart will be equal to probability for first heart multiplied by probability for second heart given the first is heart, which is 12 by 51, multiplied by probability of third heart given the first two are hearts, which is 11 by 50. Okay. So putting in these values, we get probability of first heart and second heart and third heart equal to 13 by 52 into 12 by 51 into 11 by 50. Okay, which comes out to be 11 upon 850. Thus probability that all of them are hearts in case of without replacement will be 11 by 850. Okay. Now we looked at situations wherein we are withdrawing one item at a time, either with replacement or without replacement. What happens if we withdraw more than one element at once? So if more than one item is withdrawn at once, then we find out the probability of taking out one item at a time without replacement, and they will be equal. Okay. So if I withdraw 3 items at once, what I'll do is I'll calculate the probability for taking out one item at a time without replacement. Okay, and that will be equal. So for example, probability of getting 4 hearts while withdrawing 4 cards at once will be equal to probability of getting all 4 hearts while withdrawing 1 card at a time without replacement. Okay. So now we know how to find the probability of withdrawing items one at a time without replacement. Okay. Thus we can find the probability to withdraw more than one item at once. Okay, as both are equal. Okay, so that is all about independent events and conditional probability. Thanks a lot for watching this video.